In the shell mesh example, we see some of the different algorithms to create meshes. How to set the element length and no numbering, join faces, move and paste nodes, split elements, set the quality criteria, improve the quality of the mesh, freeze areas of the model that are complete, fringe quality criteria, and finally some depth information statistics of the model. So I opened the shell mesh example, and now I switch from the topo menu to the mesh menu. Some of the geometric entities are now renamed and I switch, and the colors are also different in the mesh menu. We have the hot points as white dots, the parameters green line, macros is the faces, grids is the nodes of the mesh, mesh generation is the different mesh algorithms, shell mesh is where you can improve the quality of the mesh and elements, for example, splitting and joining. So I will start to create a simple mesh, the most fast and robust algorithm, the free. And I press the free. You have some options in the list down to the right. The element type, mixed quad triad, first order, second order, reconstruction of the mesh, improve the quality. First, I will just use the default setting to create the mesh. These options can also be found up in the mesh parameters. Okay, element type, first order. I use a free mesh on the visible. The element length is the resolution that we set when we open the model. And instead of going to the settings, change the resolution, we can use the parameter length function. Here we can select the parameter, we can make a box selection, the complete model, middle click, and now see the element length is 5 millimeters. I can, for example, switch 4 millimeters. At this time, the remesh macros was activated, and the mesh is automatically remeshed. Default is deactivated as soon as I do something with the element length, the mesh is removed. What I also can do is to set the number on the parameter. I can pick a parameter, I can pick several parameters, middle click. Apply a different number. When a different number has been applied, and the uniform element length is not correct, it means these are colored in red. So it has nothing to do with the free boundary in the topo method. It just indicates that we changed the node numbering. We can also use the number plus minus. With the left mouse button, I increase the number by 1. With the right mouse button, I decrease the number by 1. For example, in this area, if I have a mesh with no numbering on the same on the opposite side, I can use the mesh generation map. Okay, I select the faces, and we get this complete quad mesh. You can initialize all the no numbering to the uniform element length. Again, I mesh all the faces. Now we will see how to join faces, because as you can see in this area we have a very bad element. To fix this, I can join faces. Macro join. I can activate automatically remeshing, delete the remaining hot points. Just press parameter. The parameter is joined, and the face is remeshed automatically. What happens when we do the joining? We switch back to the topology module. We can see this orange cones as we have seen in previous examples. It means the different faces are joined, and there will be no meshing line. Macros release. I can take back the parameter. Maybe I click wrong. I make a box selection. We can move nodes. Grids move on the surface. You can select several points. Just drag and drop. Split elements. Split in the selection assistance. I can use the path where I select starting point and ending point, and the elements between will be split. Paste nodes. Grid space. For example, remeshing, select. Now, we will take a look at the quality criteria. So I go to the top menu, quality criteria. Shells. Just activate some default criteria, aspect ratio, skewness, warping. We can set the minimum, maximum length. Let's say 3 to 8 millimeters. Press apply. Okay. To visualize the quality criteria, go to hidden down to right. You can move this bar by pressing middle mouse a few seconds and then drag and drop. You can activate or deactivate with quality criteria by clicking. You can see it to the left, the number of shell elements and the off element is 92 elements that does not fulfill the criteria. Let's say that I had my bad elements. We can see the numbers increasing. 98 elements off. You can also right click on the off and take the show only. It will leave all the spaces that contains bad elements. Okay, I press all. Before we go to the function to fix the quality of the mesh, maybe some areas are correct, and we will not modify them. You will not modify them by the automatic function. So by activating freeze, we can freeze faces, macros. Now these nodes cannot be moved by any function. And we start to have a look at automatic improvement of the mesh. The most simple is the fixed quality. The fixed quality moves the nodes to fulfill the criteria. You cannot create or reconstruct the mesh. To use the fixed quality, middle click. I got the preview, I can invert to go back to the previous. Before we do this, it's very important to set the mesh parameters correct. I go to the mesh parameters. In this window, for example, I can freeze parameters, single boundaries. It means the nodes on a single boundary cannot be moved to improve the quality of the mesh. The most important is the fixed quality tab. And the maximum distance from surface and maximum distance from parameters. And this means that ANSA are allowed to move in the nodes 10% of the element length from the surface, from the geometry, just to fulfill the criteria. Let's say 5% is enough. The same as the distance from parameters. Okay, just move the node maximum 5% of the element length. Okay. Fixed quality, visible. We see to the left, we have 98 fade elements, now with 66 fade elements. These areas cannot be fixed with the fixed quality because the fixed quality can only move existing nodes. The next step is to use the reconstruct. The reconstruct will regenerate mesh if necessary. We can use the advanced option to select areas with failed elements. Okay, this was a hard geometry to reconstruct because it's too many small faces. So I can join some of them. Also, what you notice is that now the elements are moved from the surface. We have a distance between a node and the geometry. And this is the parameter that we set. 5% of element length is okay to move the node from geometry to fulfill the criteria. Okay, the macros is remeshed. We get some fewer off elements, 67 left. The final function is the reshape. Reshape can also do the joining automatically. The reshape can move nodes, remesh, join faces, depending on the quality criteria. The advanced option, here we have still one element off. I can try to fix this manually. Move grid. Okay, this area is very hard to fulfill all the criteria. And maybe the quality criteria are set that it can't be fulfilled with respect to the mesh parameter. The set is you cannot move the mesh more than 5% from the surface. Now, we have a look at some quality graphs. Again, I go to the quality criteria, graph parameters. Here I can fringe, for example, the criteria, aspect ratio. Okay. Activate this through the fringe button, quality graph. The aspect ratio is fringe. 1, the dark blue is perfect aspect ratio. And the maximum is 2.2. More. We can change the distance from geometry. And this was the mesh parameter that we set. And we said 5% of the element length. The element length is 5 millimeters, so 5% is 0.25. We see the red areas is where ANSA have moved the nodes to the max to fulfill all the criteria. In this area, ANSA have a lot of trouble to fulfill all the criteria. It starts to move the node from the geometry. On the other parts, the dark blue, you have a perfect fit to the geometry. Finally, we have some deck information statistics. I go to deck info and shells. We just see the basic shell info, but none and shells information. I can see it's about 4% tri-element, but now 6% quad element. I can see the minimum quad and tri-element, the maximum element, and the mean element value. And here you can get a lot more statistics of all your quality criteria. This deck info will end the shell mesh example.